Hello, everyone. Today we would continue solving questions related to phase equations of soil. So this would definitely be the last video for now that I will be doing regarding phase equation. Maybe in the future I may do some videos solving problems related to phase equation. But for now, this may be the last set of questions we will be solving before we proceed to another topic. So as you can see in the question given, so one of the things we have to do is to write out the parameters we've been given. So let's read the question together. A cubical sample of San Francisco Bay mud, that is a soft marine acidic clay, has been prepared for testing in a trutherizer device. So the dimension of the sample are parameters. The parameters given, we are given total volume, which is 76 mm by 76 mm times 76 mm. That is the total volume given. And if you convert that, total volume will give us 0.00043 meter cube, which is something as 4.3 cm cube. So that's the total volume given, and we are informed based on the parameter given. Natural water content is 68.5%, and we are told that the total density or moist density is 1.44 gram per cm cube. So the specific gravity is what? 2.55. So the first thing we are asked to find is the void ratio E, and degree of saturation S. So we have to. This is the first parameter we are asked to find for him. That is the void ratio, the degree of saturation. So for we to get the void ratio, remember from first principle, void ratio E is the volume of void over volume of solids. So what do we have to do here? So we have to work our way from the beginning, from the parameters we've been given. So let's start from with, since we're looking for volume of solid, right? It's one of the parameter, volume of solid. So let's find. So volume of solid is one of the parameter we need, and volume of void. So what we're gonna do is to just start from the parameters we know. We know that total density equals to total weight equals to total mass of total volume. So based on the question, we are not given anything like total mass yet, but we know the total volume. So we're starting from the total mass over total volume. Since the question is in density form, so it's not gonna be weight. So the next we're gonna do is that we can obtain total mass, which equals to total density times total volume. So total density we've been given in the question, which is 1.44 gram per cm cube times 4.3 cm cube. With it, we're able to know that our total mass is what? We know that our total mass is what? is gonna be 6.192 grams. So the next we're gonna do, since we know the total mass, we know that mass of solid equals to what? Total mass is, you know that mass of solid, equals to what? Total mass over 1 plus water content. So we know the total mass, so mass of solid equals to total mass is 6.192 grams all over 1 plus water content 0.685. We've been given in the question. So our mass of solid equals to, so based on that, we'll be able to obtain our mass of solid, which is a 6.1929 divided by 1.685. So with that, our mass of solid is mass of solid is what? So mass of solid equals to 3.68 grams. So that's our mass. So now we know our mass of solid. And so what else can we obtain? So we can know the volume of a solid. Since we know the mass of solid, right, we know that unit weight of solid equals to density of solid equals to what? Total mass of solid over volume of solid. So volume of solid equals to mass of solid over density of solid. So we need the density of solid, and we know that specific gravity equals to density of solid over density of water. So and we know that GS is 2.55, which is equals to density of solid is what we're looking for, right? So density of solid over density of water, which is 1 gram per cm cube. So density of solid equals to what? Equals to 2.55 grams per cm cube. That's the density of solid. So since we know the density of solid, we can now obtain our volume of solid. So we know that our density of solid is now 2.55 grams per cm cube. So we can now obtain our volume of solid, which is equals to mass of solid over density of solid, which is equals to what? Mass of solid is 3.68 grams all over 2.55 gram per cm cube. So volume of solid equals to, if you do the math very well, it's going to be 1.441 cm cube. So we've obtained our volume of solid. So what all else do we need? We need the volume of void. We need the volume of void in our equation for void ratio. So this is the equation for void ratio. And we already know the volume of solid. So what else do we need? We need the volume of void. That is what we need. And we know that volume of void, we know that total volume equals to volume of solid plus volume of void. So volume of void equals to total volume minus volume of solid. We know total volume to be what? 0.00043 cm. That will be meter cube. So the volume of void equals to the total volume, which is what? In cm cube, which is 4.3 cm cube minus 1.441 cm cube. So volume of void equals to what? So we do the calculations very well. 4.3 minus 1.441. That will be 2.859 cm cube. So that will be, convert this to 0.000286 meter cube. That is the volume of void. Then you can now obtain void ratio as volume of void over volume of solid, which is equals to volume of void is 0.000286 meter cube all over volume of total over volume of solid. Volume of solid is equals to, we can use the expressions. We can use cm cube. Volume of void is 2.859 cm cube over volume of solid 1.441 cm cube. 2.859 divided by 1.441. So void ratio equals to 1.984. So that's our void ratio. That is our void ratio. So the next thing is to obtain, that's a void ratio. The next thing is to obtain the degree of saturation X. Now from the question, so degree of saturation X is volume of water over volume of void. So degree of saturation S, this is the void, this is the volume of void. So if this is water, so we're talking about how much water is in the void with respect to the void. So based on what we have already, we know the volume of void to be what? Volume of void is volume of void is 2.859 cm. That is based on previous calculation. We know the volume of void to be 2.859 cm cube. So we need the volume of water. And we know, so how do we know the volume of water? So we know that unit weight of water, density of water equals to mass of water over volume of water. So we know the density of water to be 1 grams per cm cube, and we need mass of water. So how do we get the mass of water? We call that water content equals to mass of water over mass of solid. So mass of water equals to water content times mass of solid. And we know water content to be 0.6 based from before, 0.685, 0.685 times mass of solid. We already have that here, is 3.68 grams. So with that, we would obtain our mass of water, 0.685 times 3.68. So it's called 2.52 grams. That is the mass of water. So to get the volume of water equals to mass of water over density of water. Mass of water is 2.52 grams all over density 1 grams per cm cube. So our answer is going to be 2.52 cm cube. So that's the volume of water. So to give saturation equals to volume of water over volume of void. So volume of water is based on what we obtained, 2.52 cm cube over volume of void 2.859 cm3. If you do the math very well, divided by 2.859. So degree of saturation is usually expressed in percentage, 88%. So why this is very it's very a little bit complicated, like coming from the first principle. You need to obtain, so we obtain this using the first principle, but without stressing ourselves. For example, during the FE exam or the PE exam, when we get our equations, we don't really have much time. We have to be very fast. Speed and accuracy is one of the things you need to excel in your FE and PE exam. So when you see questions like this in the FE and PE exam, some equations can be used. Some equations can be used that would give direct answer easily without wasting much of our time. So let's see some equations that can be used. So the first one is talking about void ratio, right? First one is talking about void ratio. So let's see how we can solve this alternatively. Alternatively, we can use an equation. The equation says that we should find the void ratio E, right? And we know that total unit weight equals to unit weight of water times. Now let's talk about the density. We're using density. Total density equals to density of water times GS plus SE all over 1 plus E. And when S for dry density, that is saturation equals to 0. So the equation dry density, since this is gonna be 0 for dry density, it's equals to density of water times GS over 1 plus E. So if you make E subject to formula in this equation, you will have density of water times GS all over dry density minus 1. So this is the expression you'll be having. So for we to obtain our void ratio, we know specific gravity, right? Specific gravity is given in the question to be 2.55. Specific gravity is 2.55. So we need the dry density, which is equals to total density over 1 plus water content. And we know our total density already from the question. Our total density is what? We know our total density already, which is 1.44 grams per cm cube all over 1 plus water content. What is the water content? 0.685. So with that, we would obtain 0.855 gram per cm cube. That's the dry density. That is, when you take away water, what is the density? That is the meaning of dry density. So we already know that. So when we put that into the equation, to be what? To be 1 gram per cm cube times 2.55 all over 0.855 gram per cm cube minus 1. So this should give us same answer as the first method we use. 2.55 divided by 0.855 minus 1. So we have E equals to 1.982. So if you check this compared to this, same answer, so they should give same result. So let's proceed with our degree of saturation. Degree of saturation X. Degree of saturation X. S equals to be, it should be, using this equation to be WGS over E. That's it, which is 0.68. 0.68. What's the water content? 0.685 times 2.55 all over what? 1.98. That's avoid 1.982. So S equals to, if you do the math, you should have be 0.88, which is in percentage, which is S equals to 88%. So S equals to 88%. So this should equal the one we got initially if all things are equal. So that's how you can use equation directly without going to the first principle. So let's proceed with the question. Let's go to part B of the question. Part B of the question says, Part B of the question says what? Part B of the question says the most unit weight. We are asked to find the most unit weight. We are asked to find the most unit weight and the water content if the soil becomes saturated. If the soil becomes saturated, what does that mean? It means that find the total density. Find total density, water content when S equals to 1. What does that mean? It means that you have a void space. Initially, the total void, it wasn't filled with water. It was not fully saturated. Now, this is the volume of water. Now, what they are saying is that the volume of void, water occupies all the void space, volume of water. Now, the volume of water is the same thing as volume of void when S equals to 1. That is the situation, right? Initially, this is for S equals to 88%, and this for S equals to 100%. That is the difference. Here, volume of water is not equals to volume of void because we still have volume of air. In this case, volume of void is the volume of water plus volume of air. So that's the difference. Now we are informed that saturation equals to what? Equals to 100%. So how do we do that? So what we're going to do is to, instead that we start from the first principle, so let's start using the first principle. Degree of saturation equals to what? Volume of water over volume of void, which equals to 1 based on the information given. So we are finding the total density. Total density is what? Equals to, total density equals to total weight over total volume. And total weight is mass of solid plus total weight equals to total weight over total volume. Total weight is the total mass over total volume. Mass of solid plus mass of water over total volume. So how do we obtain this total mass? So the first thing we have to do is to obtain the mass of water. We already know the mass of solid will not increase. It is only the water that is increasing, because when saturation increases, it's the mass of water that is increasing. So we already know mass of solid. So let's just go with, let us find mass of water. Recall that S equals to WGS over E, right? We know that. And water content equals to SE over GS, which equals to our S is 1 times 1.9. We already know void ratio. The question doesn't say that the void ratio has changes. No, it's only the mass of water over 2.55. So based on this, our water content has increased 1.982 divided by 2.55, 77%. So when S equals to 88 initially, water content was 68.5%. Now what saturation has increases to 100%. So water content is now 77%. So this makes sense, right? Because initially here, water content was 88%, saturation was 88%, and water content was 68%. Now, since it has filled up the whole void space, saturation is 100%. Therefore, the water content has increased, because if it doesn't increase, it will never fill up the volume, the whole volume of void. So that is why it makes so much sense. So the next thing we have to do is to, we already know our water content, is to know the mass of water. So mass of water, water content equals to mass of water over mass of solid. So mass of water equals to water content, which is 0.77 times mass of solid. We know mass of solid from here. We already calculated that. Mass of solid. This is mass of solid here from here. We know that from before. 3.68. Mass of solid is 3.68 grams. So mass of water. So the mass of water will definitely increase, because the saturation increases from 88% to 100%, and the water content moves or increases from 88% and 68.5% to 77%. So the mass, since there is an additional water to fill up the void space, therefore the mass of water will definitely increase. So it increased to 2.83 grams. So initially, what was the mass of water? If you check very well, it should be lesser. Mass of water was 2.52. Now, due to the increase in the degree of saturation, it's now 2.83. So we know the mass of water. So we can now go ahead to say total density is equals to mass of solid plus mass of water over total volume, which equals to mass of solid is the 3.68 plus mass of water 2.83 over total volume. We know our total volume to be, we already know our total volume to be 4.3 cm cube. So if you do the math, it's going to be 1.52 gram per cm cube. So that is our new total mass due to the increase in water. We also have to find we already find the water content, which is we find this to be we already know this. We know this to be, that's our density, our total density, and this is the water content due to increase in degree of saturation. We can find this using different method, but I think we can use the same equation we used earlier, but let's just proceed with the question without wasting much of our time. So we asked to find the density of the soil if all pore fluid is dried off with no change in total volume. So we asked to find the density. So we asked to find the density. We asked to find the density. That's dry density. If what? If all water they are dried off. Sorry for that. So we asked to find the total density. Let's go to the question again. So the question says find the density. You have to find the density. So the question is the question is moist density. Yeah, that is the question. Moist density. Moist density. We're finding moist density. The moist density, the moisture, if soil becomes saturation, the density P of the soil, if all pore, the density P, the density P, that's the last question. So density is going to be the density P. So they say if the water is dry, that shows S is 0. And recall, total density equals to what? Into the water times GS. No. Total density equals to density of water times 1 times GS plus SE over 1 plus E. So if the soil is dried, that is S equals to 0, water content 2 equals to 0, typically. So total density, so for dry density to be density of water times GS plus 0 over 1 plus E. This equals to 0 for dry density. So this is equals to 1 grams per cm cube times 2.55 all over 1 plus 1.982. So I think we already find this initially. This equals to 0.854 grams per cm cube. We already determined this earlier when we're trying to find one of the parameter here. I think we already get this here. So that's how to solve that question. If you have any question, please leave it in the comment section. So that's how we were able to solve this kind of problem. So let's go to the second question for today. The second question for today. This is the second question for today. Just very straightforward, like we should just work together. So it says the sample of soil was taken from below. So most of the time we have sand when you do your exploration, the boring log. Your boring log information. We have sand, most of the time we have clay, sometimes we have sand. So most of the time, let's say what I hear. So when you pick a sample at this point, you pick a thin wall sample, U1, it's below water table. It's below water table. So technically, all the void will be filled up with water. So we say S equals to 1. So any clay or fine grain sample that is obtained, any cohesive material that is below the groundwater table, the degree of saturation is 1. It's 100%. We assume that the void space has been filled up with water. It may be in the real lab test, maybe about 98%, 97.5%, but for this purpose, most of the time we usually assume that it's gonna be fully saturated. So S equals to 1. Even though it's no state that we know, S equals to 1 because the sample was obtained below the groundwater table. Not sure how much soil contains 52%. G specific gravity is 2.69. We have to determine the moist unit weight, that is total unit weight. We have to determine the total unit weight. Record that total unit weight equals to, if you check your manual, you will see that it equals to unit weight of water times GS plus SE over 1 plus E. Right, that is the total unit weight that we've been asked to find. But we don't know the void ratio, right? We know saturation is 1. We don't know the void ratio. So we have to use this equation. S equals to WGS over E. E equals to what? WGS over S equals to water content is 0.52 times 2.69 over 1. So 2.69 times 0.52. 0.52. So with that, we know that our void ratio is 1.40. So total unit weight equals to 62.4 pounds per feet cube times GS 2.69 plus 1.40 all over 1 plus 1.40. So if you do your math properly, your total unit weight in pounds per feet cube is going to be 6.3 pounds per cubic foot. Then to obtain your, that's the first one, moist unit weight or total unit weight. Second one is the dry unit weight. We already know that dry unit weight equals to total unit weight over 1 plus water content. 106.3 over 1 plus 0.52. 106.3 divided by 1.52. So it equals to 70 pounds per cubic foot. This is the answer. And the last question says, no, option C say we should find the buoyant, which is total minus unit of water. That is the equation for effective unit weight. Total unit weight minus unit weight is equal to 106.3 minus the unit weight of water is 2.4. So our answer is 44 pounds per cubic feet. So the next, based on the question, we are asked to find, the void ratio E. How do we find E? We already find E to be what? 1.40. That is D. That's our question D. And our question E, porosity is E over 1 plus E. We already established how we get this. We know that volume of void ratio is volume of void over volume of solid. Porosity, volume of void over total volume. If you take this volume of void divided by volume of solid, total volume is volume of solid plus volume of void. So volume of solid divided by volume of solid plus volume of void divided by volume of solid. This is 1. If you check this to be E over 1 plus E, so 1.4 over 2.40. It's usually in percentage, which is 34%. So that is how to solve this kind of questions. If you have any question, please leave your question in the comment section. Please share this video, like this video, and subscribe to the channel, as we would bring more interesting and educative content to your doorstep, bringing it closer to you. And that is one of the goals of the YouTube channel, to bring geotechnical engineering classes to closer to you. Please subscribe, share this to friends, and see you in the next video. Thank you.